Hi, I'm Adam and this is my third video in the Duino-Coin mining series, and in this video we're going to lay out the PCB for this USB miner. So let's get started right now. This video is sponsored by PCBWay.com. The USB miners featured in this video series are made using PCBs manufactured by PCBWay.com. At the time of recording, PCBWay are offering up to 20% off on all 4 and 6 layer PCBs. To grab a quality PCB at a great price, upload your Gerber file to PCBWay.com for an instant quote. Now let's export the Netlist for use in the PCB Editor. So, File, Export, and select Netlist. With the KiCAD tab selected, click Export Netlist. This is my project folder, so I'll just click Save. Go back to the main project and open the PCB Editor by double-clicking the file ending in KiCAD_PCB. The first thing we're going to do is fill out this section, just like we did in the schematic. That's done by clicking this button to open up the page settings. So I'll be using today's date, and the revision is 1.1. The title is Duino-Coin Miner PCB, and the company is iNimbleSloth.com. Great, that's done. Next, let's import the Netlist. So, File, Import, Netlist. Browse to the location of the Netlist that we just exported, select it and click Open. Click Load and test Netlist. Great, no errors or warnings. Next, click Update PCB and close. When we first import a Netlist, all of the components are stuck together like this and stuck to the cursor. We just need to place them somewhere out of the way, so I'm going to place them up here. Click to place them. These lines going between the components are called a rat's nest. They represent the electrical connections. KiCAD 6 now has the new feature of curved rat's nest, which is this button here, and I think is a little easier to see. This button toggles the rat's nests on and off, and this button toggles between the straight or curved rat's nest lines. Before I start to lay out the PCB, let's just take a quick look at what we already have. Here you can see all of the components on a PCB, and we get this warning message about the board outline is missing. To make it a little easier to align everything, I'm going to switch to the full screen crosshairs with this button. I'm going to decrease the snap to 0.127mm as we are working with such small components. Right. To draw the PCB edge, select the Edge Cuts layer and the Straight Line tool. Click where the line should start and press the spacebar to zero the coordinates at the bottom of the screen. We need a line that is around 64mm long. This will do. We need to make sure that the line is level, and we can do this by checking the dy value at the bottom of the screen. It should be 0, assuming that you did reset the coordinates with the spacebar when I did. Click to set the endpoint of the line. Press space again to reset the coordinates. Now we're going to come down by about 20mm. OK, this will do. Make sure the line is level, so that means the dx value should be 0 this time. Click to set the endpoint of the line and press the space to zero the coordinates again. And my first line was 64.389mm. Ensure that the dy value is 0 so that we know the line is level. And then click to set the endpoint for the line. Press space again to reset the coordinates. And now we just need to draw a straight line up. Let's take a quick look in 3D. Here's the PCB, and we just need to arrange these components to fit on it nicely and route the traces between the components. Right, I'm going to save this before moving on. I like to round the corners off, as I feel it makes the PCB look a little bit more aesthetically pleasing. We can do that with this tool. We need to decide how far to come in and then round off the corner. Zoom in and place the cursor on the corner, then press space to zero the dx and dy coordinates. Then come in by 2.54mm for both dx and dy. Click and expand the circle like this. Then click and draw in an anti-clockwise direction. Click to set the endpoint. Double tap the escape key so that no tools are selected, and now select the edge of the PCB and drag the line down until it meets the end of the curved line. Do the same for the top line. Now repeat for the 3 remaining corners. Looking good. Let's check it out in 3D. So that's Alt and 3 on your keyboard. Now we have these lovely rounded corners which I think you can all agree look much better than the sharp 90-degree right angle corner. So next we'll arrange these components onto the board. Let's start with the USB connector. To ensure that the connector sits centrally, I'm going to place a grid origin point. So that's place and then grid origin. Place it right where the lower left corner originally was. Preferences and then Preferences. Select Origins and Axes. Then set Display Origin to Grid Origin and click OK. Now this becomes 0, 0. So we know that this line is y equals 0. We know the width of the PCB is 20.32mm. Next, let's edit the footprint for the USB connector so that its 0 coordinate is in the center instead of its lower left corner. Select the footprint and press the E key on your keyboard, and then select the Edit Footprint button. This little purple cross is the 0, 0 coordinate. Select everything and move it so that the purple cross is in the center vertically. Once happy with the position, click Save. Now you can see the purple cross is in the center of the footprint, so all we need to do is align this centrally along our Y coordinate for the PCB. With the footprint selected, press the E key on your keyboard. And we know that the purple cross is in the center of the footprint, so all we need to do is place that purple cross in the center of the board, which is 10.16mm. Let's take a quick look in 3D. Fantastic. Now let's get the rest of the components onto the board. Don't worry too much about exact placement yet, just place them in a similar position to me. You can see by the rat's nest which component is linked to which, so we can place them accordingly on the board. If we look at the rat's nest for the UART, we can see that it should be rotated so that it is easier to connect to the USB connector. Now I'll speed up the placement of these components, and if you are following along, there are some screenshots on my website showing where I placed them. The link to these screenshots is in the description. To keep the size of the PCB down, I'm going to place the remaining components on the underside of the board. To do this, select the component, press the E key, and change the side to back. Do that for each remaining component. Notice how the colour of these components has changed. This shows that they are on the rear layer of the PCB. Now position them on the rear of the board. It can help to hide some layers when doing this. Now let's give it a quick check in 3D. Right, it's looking quite good now. Let's make all of the layers visible again. Next, I'm going to tidy up some of the silkscreen. Before starting to lay out the tracks, we need to define the widths and clearances that we want to use. So come up to here and select Board Setup. Then select Net Classes. The default class is suitable for the signal tracks and within PCBWay's manufacturing specifications. With this we get 0.2mm clearance between tracks, 0.25mm track width, etc. I'm going to add another net class for the power tracks. To do this, click the plus button. And let's give it the name Power. I'm going to assign the clearance 0.25mm and a track width of 0.4mm and the via size of 1mm. Then once you've defined the new power class, it's necessary to assign it to whichever net you want to. So in my case, I'll assign it to the GND net, the VCC net and the VSub net. Now, when I draw a track for any of these nets, it will have the newly defined properties above. OK, time to draw the tracks. Select the Root Tracks button on the copper layer you wish to draw on. I'm going to start with the bottom copper layer. Hover the cursor over the pad and left click to start drawing. Then left click whenever you want to add a bend. Let's connect this GND pad to this one. And let's connect this GND pad to the GND pad on the oscillator. Next, I'm going to switch to the top copper layer. And notice how this track is thinner as it's the default net class. Right, you get the idea, so I'm going to speed up this next section. Again, there are some images on my website showing the track layouts. And again, you'll find the link in the description. When you come across a situation where you need to take a track from one side of the board to the other, you can use a via to do this. Let's start by drawing a track from pin 13 of U1 and double click to stop the track without connecting the other end to a pad. Now select the via button and drop this via over the top of the end of the track. There are rules in place that stop the via being added too close to a pad or another track, so you may have to play around a bit to get it to fit. Then switch to the other copper layer and select the Root Tracks button, then continue to draw a track from the via to the destination pad. Remember when I said I'd made an error in my schematic and missed off a GND symbol? Well, this is the point I realised I'd made that error. So I added one in the schematic, saved it and re-exported the netlist. Then back in the PCB editor, it's just a case of importing the updated netlist. Now you'll see that pad 2 of C6 and C7 both belong to the GND net. I just need to delete this track and redraw it so that it uses the PowerNet class specs. Right, that's better. It's wider now. Right, it looks like all of the tracks are now routed. Time to save and run the design rules checker, which will check the layout meets the net class specs. So to do this, click the DRC button and then Run DRC. Okay, I've got one warning. This is why it's super important to run this. Right, let's check out what that warning is. Double clicking the warning shows an arrow where it is. In this case, it's a rogue bit of track that isn't connected to any other net, so I just need to select it and delete it. Then rerun the DRC. Excellent, no more errors or warnings. Now that the tracks are laid, I want to add a copper fill to both sides of the board, and then this copper fill will be connected to the GND net. To do this, select the Add Field Zone button and the desired copper layer. I've already got the bottom copper layer selected. Next, zoom into one of the corners. It doesn't matter that I'm off the PCB since anything past the edge would be ignored. Left click and then select the net that this copper fill should be attached to. So in this case, I'm selecting the GND net. Here you can adjust the clearance from other tracks and pads. I'm going to go for 0.254mm. Now click OK. Now we draw the outline covering the entire PCB. Left click when you need to change direction and double click to finish. Notice how the field zone is shown by these angled lines at the edge of the board. If we click this button over here, it's possible to show the filled area as solid. Now press the B key on your keyboard to fill the zone. Let's take a quick look in 3D by pressing Alt and 3. This is what the copper filled area will look like. And notice the corners. Since we defined a clearance of 0.254mm, the copper stays within the PCB edge by this distance. Right, now let's switch to the top copper layer and repeat. I'm going to set Remove Islands to Never. This means that if there would be an island of copper created that can't be connected to the GND net, KiCAD will leave the copper island in place. Great, let's save this and then check it out in 3D. So that's all of the components, tracks and copper fills done. All that's left is to add some text and images to the silkscreen. I'm going to add a Duino-Coin logo to the board and I've already got this as a PNG file. From the main KiCAD window, select Image Converter and then click Load Bitmap. Browse to the folder containing the image you want to use. Select the desired image and click Open. Once imported, ensure that you select Footprint, and then we need to adjust the size as this is far too large to fit on my board. To help select the correct size, let's measure where I plan to put the logo. Select the measuring tool, click to start, and from here I can see I have around about 5.5mm. Right, back to the image, and I'll enter 5.5 for both height and width. With footprint selected and front silkscreen selected, we just need to click Export to Clipboard. Now back in the PCB Editor, ensure that you have no tool selected and paste using Ctrl+V. Okay, this might be a little too large, so I'm going to go back and reduce the size to 5 by 5mm. There, loads better. With the image selected, press the E key on your keyboard to edit it, and here you can see the reference designator which we don't want. So change the layer to front fabrication and deselect the show checkbox and then click OK. Repeat the process for any other graphics that you want to add. Let's check it out in 3D. Looking great. Next, I'm going to add another image and some text to the rear of the board. The text will be version number and what the device is. To help see what space is available, I'll hide some of the top layers. Notice that the image is on the front silkscreen. To get it on the rear of the board, select it and press E on your keyboard. At this drop down, select back and then click OK. Notice that the image is now reversed, as we are looking at it from the top. With the image still selected, press the E on your keyboard again. Now change the reference designator to front fabrication and deselect the show checkbox. Click OK and then position the image where you want. I feel that this could be a little larger. There, that's much better. Now all that's left is to add the text. Use the text tool to add your desired text and adjust the layer and size accordingly. Great, I'm really pleased with this, so I'll run the DRC one more time just to make sure I didn't break something. Fantastic, no errors or warnings. The very last thing we need to do is export the Gerber file for manufacture. To see how to do this manually, check out my Commodore 64 cartridge KiCAD video series, the link is in the description. Since releasing those videos, I've discovered a great plugin from PCBWay, which exports the Gerber files and automatically uploads them to the PCBWay website ready for ordering. How cool is that? Installation is super easy. Navigate to the main KiCAD window and select Plugin and Content Manager. Then search for PCBWay and click Install. To use the PCBWay plugin, simply click the button and watch it work its magic. Then boom, the PCBWay website opens up with the Gerber file already uploaded, and here you can see my board. Right, I want shipping to the UK. Then it's just a matter of selecting the PCB specifications and the colour that you want. Here, green is coming out the cheapest. I'm going to order this board in green, and I've also designed a surface mount version which I'll order in white, so you can see the two colours in the next video where I'll be soldering the components into place and showing you how to use these boards to mine Duino-Coin.